In this video, we'll implement a single frame buffer on two different boards, one with LTDC and one with FMC 8 bits. Hello and welcome to this How to TouchGFX video. My name is Gaëtan and today we'll see how to implement a single frame buffer strategy. Here is the result that we will achieve. A simple GUI running on two boards, both running single frame buffer strategy. We will start by looking at the different render time scenarios and then we'll implement the strategy, first with LTDC, which is very fast, and then with FMC 8-bit, which is custom. We previously saw the general mechanism of the single frame buffer in the video Frame Buffer Strategies. In this strategy, TouchGFX is aware of where the display controller line is, and can therefore start rendering right after it. The display control line is also called scan line. This gives us more flexibility in render time, which is greatly appreciated when we don't have DRAM. As usual, you should try to make sure your render time is 16 milliseconds or less. This is what you see on the screen right now. You see the DC line going down and the new frame being rendered on time. Making sure that the frame is rendered on time allows this loop to be perpetual, so we don't skip a frame and we don't have tearing effect. Now let's say that we have made a GUI that renders in more than 60 milliseconds but less than 32 milliseconds. That is the case of the animation that you see right now. TouchGFX will start to render a new frame only once the DC line has started. This way the DC line will start moving, and after 60 milliseconds it will loop back. Then it will start rendering the beginning of the frame, which allows us to finish the end of the frame while we are transferring. In that case, we must skip one frame, which gives us half the effective FPS, but we are still able to prevent tearing. There is, however, a case where we'll have tearing effect even if a frame is less than 32 milliseconds to render. If in the upper part of the screen we have an heavy asset, such as a complex SVG, the rendering will slow down in that specific area of the frame buffer. It means that during the second loop, the DC line will catch up with the rendering line, even if the total rendering time is not that long. Let's have a look at this case. We see a fast rendering, but now it's starting to slow down because we have to render the SVG. Then the DC line will catch up, and as soon as it crosses the render line, we will have tearing. This is why we recommend to not use heavy asset in single frame buffer strategy without DRAM, or to thoroughly test your GUI before. If the render time is over 42 milliseconds, then there is no way to prevent tearing if we don't have DRAM. As the DC line starts moving, the rendering starts as well, and it will eventually catch up. The first frame buffer strategy change that we will do will be on the STM32U579ZI Discovery Board 2. So let's create a new project with that board. We can now open the STM32CubeIDE project, build the project, and look at the memory mapping. Here we see the frame buffer region that has 3 memory addresses. This is the frame buffer itself. Now let's go back to STM32CubeMX and change the frame buffer strategy from double to single. Now we'll regenerate the code. Let's build again in CubeIDE and look at the memory map. Here we see that the frame buffer size is now half of what it used to be. Because this is an LTDC display, TouchGFX is already aware of the display transfer line position. So we do not have to add extra code. The frame buffer change is already finished. Now it's working. So LTDC displays are a great way to implement single frame buffer strategy on TouchGFX. Unlike LTDC, 8-bits FMC doesn't have much code that is generated by TouchGFX Designer. So we'll have to look at the documentation and modify the code ourselves. You can find a link to the documentation in the description of the video. Just like before, we'll start by creating the project. This time it will be a STM32U575. Then we can open the IOC file and switch from emulated frame buffer to single frame buffer and generate the code. Even if you switch from emulated to single frame buffer, the code for the emulated frame buffer remains. So we'll have to remove some function and some variables that are not used anymore. Let's open the folder TouchGFX, then target, then the file TouchGFX.hal.cpp. Let's remove the variables that were used for the emulated framebuffer. These are the ones such as eSteering block or start rendering immediately. Also, we will remove the function for the partial framebuffer at the top, as well as the function displayDriver transfer complete callback. Finally, we will remove the task entry in the CPP and HPP that we don't use anymore. The last step is to modify the function that used the previous variable. Let's look at the following callback function and remove the timer. Now we will implement the single framebuffer strategy thanks to the documentation. As we saw in STM32CubeMX, FMC 8-bit is considered custom, so the functions are not generated. So we will follow the documentation to be able to implement the strategy. First, we'll add the two following lines. One is to add a delay that we will use as a timer, and the other one is the single framebuffer refresh strategy. Now let's look at the function rising callback. It already exists, but this is the wrong implementation compared to the documentation. So let's correct that. This function is crucial. It is called at the beginning of a new frame. You can also see that we use variables called refresh min line and refresh max line. They are used to limit the area that we will transfer. So, for instance, if the 21st line of the screen are the same as previously, we will skip them. We will only start transferring from the line 20. This allows us to skip transferring information that is not changed. Now let's move to the function flush framebuffer. Again, it has changed. It's not the same, so let's copy it. The function sendNextFrame buffer block to display is not declared, so let's declare it and define it. This function is crucial for the strategy. It allows to send only a few lines at a time. And in between each call of this function, we use the delay that we defined earlier. The next step is the function DMA callback. We have to modify it to match the new framebuffer strategy. This function allows us to move down the transfer line. So if you don't implement it, only the top part of the screen will be sent. Later on, when we have a working project, you can try to remove that function to see how it affects your display. We also have to change the function beginFrame as follows. This function resets the variable refresh minline and refresh maxline for the incoming frame. If I try to run the program like that, I will get a few errors. First, we can see that with that new implementation, I'm using variables that I did not declare. For instance, display DMA is not declared, but actually display DMA is just the DMA handle. So let's add the following line. Now we also have to add all the variables that we added in the new functions. Max block height is the number of lines that we send between each delays. We also see the refresh min line and refresh max line that we talked about earlier. Also, after the initialization, we need to add framebuffer equal framebuffer 0. This is so that the framebuffer is accessible in that area. Let's compile and see that we don't have errors anymore. In this video, we saw how easy it is to implement a single framebuffer strategy on various displays. This strategy allows us to save memory while keeping good performance in an efficient way. To make this strategy efficient, we start rendering the frame right after the DC line or the DT line. Also, we are able to skip the first line or the last line if they have not changed. If you want to keep learning, you can check our documentation, our API, and our tutorials on our website. Please find the link in the description. Also, you can check our other video in this playlist where we talk about various subjects. Finally, if you have a specific question, you can ask it on the ST community forum. Thank you for your attention and see you in the next one.